Hi, I'm Zoe and I'm going to be doing lesson 5.4, Indefinite Integrals and Net Change Theorem. Two important integral ideas to remember is that if you're taking an integral from constant a to the same constant a, the answer is just going to be 0. Because if you're taking the area under a curve and you're not moving anywhere, you're just going to have no area. The second idea is that if you're taking the integral from constant a to constant b, it's the same thing as taking the negative integral from constant b to constant a. As we can see, using the first fundamental theorem of calculus, the answers are the same. Something that we're going to see with even functions is that if you take the integral from negative a to a, it's the same as doubling the integral from 0 to a, because even functions have symmetry across the y-axis, so the areas are going to be the same on both sides. With odd functions, we're going to see that taking the integral from negative a to a is 0, because odd functions have symmetry across the origin, so the area on one side is going to be the exact opposite of the area on the other side. Now we're going to talk about indefinite integrals. While a definite integral is taking the antiderivative of a function with specific limits, an indefinite integral is taking the antiderivative of a function without specific limits. The common notation of an indefinite integral is f of x, but with a capital F. An important thing to remember when taking an indefinite integral is to write out the integral and then add a plus c at the end, because an indefinite integral is a family of functions, not just one specific solution. Here are some common indefinite integrals that you should be able to remember. The net change theorem simply states that if you take the definite integral of some sort of rate, then your answer is going to be a quantity. And we're going to talk more about this by doing some example problems. Another specific part of the net change theorem is the idea that there's a difference between displacement and distance. So for displacement, if you're given the velocity function, you're going to take the integral of that function just as it is, and that's the displacement, because that will account for the negatives and positives of the velocity. Distance, on the other hand, is only based on the speed, not necessarily which direction it's going in. So distance is going to be the absolute value of v of t, and you're going to take the integral of that whole thing. A quick example of this is just if you're given some velocity function, v of t, if you're looking for the displacement, you can just take the integral as it is. And that's going to give you how far away whatever is moving is from the original position it was. And if you're looking for the distance, you have to take the integral of the absolute value, which is a couple more steps, but that'll give you the total distance traveled, not just how far away it is. To get some more practice with the net change theorem, we're going to be doing AP Calculus AB 2002 FRQ question 2. The question states, the rate at which people enter an amusement park on a given day is modeled by the function e, defined here. The rate at which people leave the same amusement park on the same day is modeled by the function L, defined here. Both E of t and L of t are measured in people per hour, and time t is measured in hours after midnight. These functions are valid between 9 and 23, the hours during which the park is open. At time t equals 9, there are no people in the park. Part A asks, how many people have entered the park by 5 p.m., or t equals 17? Round your answer to the nearest whole number. So this is where we can use the net change theorem, because since E of t is a rate, taking the antiderivative of that rate will give us a quantity, or the amount of people that have entered the park. So what we're going to do is take the antiderivative of E of t from 9 when the park opens to 17 with respect to t. Now on the AP test, all you're going to have to do is write out the correct integral, and then you can just plug it into your calculator and solve, which is going to give us 6,004 people. Part C of this problem says, Let h of t equal this. The value of h of 17 to the nearest whole number is 3,725. It asks you to find the value of h prime of 17 and explain the meaning of h of 17 and h prime of 17 in the context of the park. For this problem, we aren't worried too much about solving it so much as understanding what h of 17 and h prime of 17 mean. We would get that h prime of 17 is equal to negative 380.281 because you always round to 3 decimal places on the AP test unless otherwise told. So what's important for us here in this lesson is understanding what the meaning of h of 17, h prime of 17 is in the context of the park. Since they give us h of 17 is 3,725 and its integral of the difference of these rates, that means that h of t by our net change theorem is going to be a quantity. So that can tell us that this h of 17 right here means 3,725 people because it's a quantity and people are a quantity. And because h prime of 17 is the derivative of a quantity, that means it's going to be a rate, which means that we're going to know that the number of people in the park was decreasing at 380.281 people per hour at time t equals 17, so 5 p.m. To practice some indefinite integrals, I'm going to throw a couple of problems at you that use the integral rules I gave you earlier in the video. So for this one, you're just going to have to remember this structure and realize that it's going to be sine inverse of u, which is 1 over square root 1 minus u squared. And in this case, our u is going to be 9x squared. And the reason for that is because if you see here, this is going to be squared, so you basically have to look at this whole thing squared, and the square root of this would be 9x squared. And our du, because we're going to have to use a little bit of u sub here, is going to be 18x dx. And as you can see, that doesn't completely cancel out, so that's going to leave us with a 1/2 out in front of our answer, and give us 1/2 sine inverse 9x squared. And you have to remember the plus c here, because this integral is not a single answer. It could be any variety of answers because we don't have those limits here as we do on a definite integral. So on a multiple choice, it might be a little bit easier because it'll have the plus c, but on a free response, you always have to remember to put that plus c at the end. This is a special case because if you think about this, this is also the integral of x to the negative 1, and adding 1 would give us a 0, which would end up being 1 over 0, and that doesn't work. So this is a special case in one of the rules where it's actually going to end up being ln absolute value of x. You have to remember that absolute value plus c, of course. You could get confused again if they give you something to the effect of 1 over 1 plus y squared dy, the integral of that. And if you look at that, you might try and use this ln rule, but you have to remember this structure is actually equal to the tan inverse of y. And that's a common mistake that you're going to see sometimes yourself doing, and that's okay. You just have to recognize the structure because the structure is extremely important in these kinds of problems and giving you clues on how to solve them.